brazing, or more specifically, braze welding. So I'm going to give a demonstration of braze welding two pieces of carbon steel together. Now the difference between brazing and welding is that in welding you're going to melt the base metal and then add the filler metal in. So you're going to get a complete joint that's totally different from all three component parts. Each of the base metals you're joining and the filler metal. In braze welding, you have your filler metal, but you do not melt the base metal. So in this case, I'll join two pieces of metal together, but neither of these pieces of metal actually gets melted. Right? The brazing filler, this bronze rod stuff, is going to essentially act like a really strong glue. Now, in order to get a really good bond, just like any other kind of glue, you need good surface conditions for the base metal. So we accomplish this with mechanical cleaning, aka grinding or wire wheeling, shot blasting, or even wire brushing, making sure the surface is clean, and with a flux. There's all kinds of fluxes, but for steel and most cast iron, a general purpose brazing flux will do, which is what we have right here. Now, there's all kinds of different brazing fluxes. The one I'm using today is a powder, and I'll apply it to the filler metal before I apply it to the joint. So I'll demonstrate how that works in just a second. Now, in the actual process, I'm going to use an oxyacetylene torch with a neutral flame to heat up that base metal until it's, kind of a glowing cherry red. I do not want to melt the base metal. I can pay attention to the filler metal to see if I'm at the right temperature. If the filler metal doesn't do anything, it's probably not hot enough. But if the filler metal is jumping around, like if you have a frying pan and it's really hot and you throw butter on it and it just kind of hops around, I'll know the base metal is way too hot. So I'm looking for a middle zone where my filler metal just flows out. Now, with braze welding, you're not going to get nice looking welds like you would if you TIG welded or even were really careful with gas welding. The filler metal is going to kind of go all over the place. That's okay, because bronze filler metal, at least, is easily machinable. It's easy to grind and clean up, although it will be a different color than the base metal, so it depends what you're repairing as to whether that will be acceptable or not. Now, this kind of filler metal, this kind of process is great for gray cast iron because you're not melting that cast iron, not releasing all that carbon, all those graphite flakes into the weld. So you're just adding the bronze, which is pretty ductile, to the cast iron, and typically get a pretty good weld. As far as safety is concerned, I have on long sleeves, I'll wear gloves, safety glasses, and a welding helmet. It's possible to do brazing with just welding goggles, but I don't prefer it because occasionally some hot splatter or metal will jump up and hit you in the face. I like the full face shield. I'll use about a number 5 darkness of my screen. You don't want to use a normal welding shield because it's too dark and you won't be able to see what you're doing. Gas welding and gas brazing are not nearly as bright as arc welding. So I'm going to go ahead and get my torch lit. Like I said, I want basically a neutral flame, which means we're getting half oxygen, half acetylene, not more of one than the other. So we got a nice flame going. I've got my filler metal. I'll get the joint arranged how I want it. Now, First thing I'll do is apply a little bit of heat to the metal to get it toasty. Then I'm going to take my filler rod, heat up about 2 inches of it, dive it in that flux. That way we get the flux on the filler metal and we'll be ready to go. So at this point, we're ready to drop my shield and go ahead and weld this up. Like I said, I'm going to get it cherry red, apply the filler metal until it fills the joint. So that's all there is to it. I've got a braze weld. Of course, it doesn't look super great. The filler metal tends to just run wherever it wants to, but this is what we end up with. On the back side, we can see where it went underneath the joint and through it and filled out pretty well. This is nearly as strong as oxyacetylene regular welding. The tensile strength is going to be about the same, except at high temperature. So after a couple 100 degrees, this bronze will lose most of its strength. So there's definitely more to it than that, but that's the basic process of how braze welding is done.